This is the video for Algebra 2B, Part 16, Task 3, Conditional Probability. So recall from Task 1, to calculate a probability, we take the number of ways an event can happen and we divide by the total number of outcomes. Let's keep that in mind as we talk about calculating conditional probabilities. So a conditional probability is the probability that event A will occur given that another event B has already occurred. So that's knowing that something has already happened is gonna change the probability of our event. So in the notation, A with a straight up and down line, vertical line B, means what's the probability? I'm gonna abbreviate here, the prob. So probability of event A given event B has already occurred. Okay? There is a formula that you can use to calculate this probability. The probability of A given B is actually the probability of A intersect B, okay, so A and B occurring, divided by the probability of B. So notice that the bottom probability is always the given probability. So that event that already happened. The probability of the event that already happened. Now, most of the time, with a lot of these, we can actually calculate conditional probabilities without even using the formula and just kind of thinking back to how we calculate probability in the first place. Okay, so let's try this example. In a class of 100 students, 49 are male, 51 are female, 45 of the females have a pet, and 8 of the males do not have a pet. So let's break this down a little bit before we go much further. So we have 49 males. I'm going to do some abbreviation here. Let's say P for a pet, NP for no pet. So there's 49 males. Of those 49, 8 of them don't have a pet. So NP, the no pet, is 8, which means there are 41 males that do have a pet. Okay, so that's the males. Let's put an M up here so we remember this is the males. And then with the females, we have a total of 51 females. Let's do P for pet, NP for no pet. 45 females have a pet, which means 51 minus 45, 6 females don't have a pet. Okay, those numbers will be helpful as we calculate these probabilities. So what is the probability that the student selected has a pet given that they are female? So if we think about our probability, our fraction, the number of ways that that event can happen divided by the total number of outcomes. What happens is when we're given a conditional probability, when we know something has already occurred, that may affect either the top of our fraction or the bottom, or both. In this case, because I know it's a female, I know that it has to be, there's 51 total outcomes for that to happen. It can only be a female, so the total number of outcomes changes from 100 total students to just 51, the 51 females. So of those 51 then, what's the probability that I select a student who has a pet? Well, if we look at the females, 45 of them have a pet. So the probability that a student selected has a pet, given that it's a female, 45 out of 51. Okay, B, what is the probability that the student selected is male, given that they have a pet? Okay, so we know this student has a pet. So that's going to, again, affect our total number of outcomes. So let's calculate how many people do have a pet. So we have 41 males that have a pet, and we have 45 females that have a pet. So we have a total of 86 people who have a pet. So that's our total number of outcomes. We know that it's a person with a pet. What's the probability then that the student we select is male? Of those 86, 41. 41 of those are male. So our probability is 41 out of 86. What is the probability that the student selected has a pet, given that they do not have a pet? So we know they don't have a pet. So there's 8 males that don't have a pet and 6 females that don't have a pet, so that's 14. Of those 14, what's the probability that they have a pet? How many of those 14 have a pet? Well, the 14 is they don't have a pet. So this doesn't make sense, does it? If we know that the person doesn't have a pet, then the probability that they do have a pet, there's none of those. So our probability here is 0. And if we look at a notation question for two events A and B, the probability of A is 0.15, the probability of B is 0.3, and the probability of A and B is 0.06. What's the probability of A given B? So it's good to pay attention to what the given is, because that's the probability that should always go on the bottom of your fraction. So we want the probability of B on the bottom. So the probability of A intersect B is on top, so 0.06 divided by the probability of B, 0.3. 0.06 divided by 0.3, if you use a calculator, you're going to get 0.2. 0.2 is our probability of A given B. Now that's the end of this video, so give the practice problems and activity 2 a shot.